We live in a universe powered by nuclear reactions. These reactions are the fundamental processes that drive the energy production in stars, and by extension, the energy we harness here on Earth. The power of the atom is both awe-inspiring and humbling, reminding us of the immense forces at play in the cosmos. Stars, those distant suns scattered across the cosmos, shine because of the energy released deep within their cores. This energy is the result of nuclear fusion, a process where lighter atomic nuclei combine to form a heavier nucleus, releasing vast amounts of energy in the process. It's this energy that makes stars visible to us, even from light years away. This energy comes from the very heart of matter, the atom, and the forces that bind it together. Atoms, the building blocks of the universe, contain a nucleus made up of protons and neutrons, surrounded by a cloud of electrons. The forces that hold these particles together are incredibly strong, and when these forces are manipulated, they can release tremendous amounts of energy. In the vastness of space, nuclear reactions are commonplace. They occur in the hearts of stars, in the explosive deaths of supernovae, and in the formation of new celestial bodies. These reactions are responsible for the creation of the elements that make up everything we see around us, from the air we breathe to the ground we walk on. On Earth, we've learned to harness this power, for better or worse. Nuclear power plants use controlled nuclear reactions to generate electricity, providing a significant portion of the world's energy needs. However, the use of nuclear energy is not without its challenges and controversies. Nuclear power offers a glimpse into the awesome forces at play in the universe. By tapping into the energy stored within atoms, we can generate large amounts of electricity with relatively small amounts of fuel. This makes nuclear power an attractive option for meeting the world's growing energy demands. It allows us to tap into the very building blocks of matter, releasing energy that can be used to power our world. The process of nuclear fission, where atomic nuclei are split to release energy, is the most common method used in nuclear power plants today. This process generates heat, which is then used to produce steam that drives turbines to generate electricity. But this power comes with great responsibility, demanding careful consideration of both its benefits and its risks. The potential for accidents, the challenge of managing radioactive waste, and the threat of nuclear proliferation are all serious concerns that must be addressed. Ensuring the safe and responsible use of nuclear energy is a critical task for scientists, engineers, and policymakers. There are two primary ways we can harness nuclear energy: fission and fusion. Each method has its own advantages and challenges, and both hold the potential to significantly impact our energy future. Nuclear fission is the process of splitting atoms, a bit like striking a match on the cosmic scale. When a heavy atomic nucleus, such as uranium or plutonium, absorbs a neutron, it becomes unstable and splits into two smaller nuclei, releasing a large amount of energy in the form of heat. This heat is then used to generate electricity in nuclear power plants. This splitting releases energy in the form of heat, which we can then use to generate electricity. The heat produced by fission is used to convert water into steam, which drives turbines connected to generators. This process is highly efficient and can produce large amounts of electricity with relatively small amounts of fuel. Nuclear fusion, on the other hand, is the process of fusing atoms together, mimicking the reactions that occur within the heart of stars. Fusion involves combining light atomic nuclei, such as hydrogen, to form a heavier nucleus, such as helium. This process releases even more energy than fission and has the potential to provide a nearly limitless source of clean energy. Fusion has the potential to provide near-limitless clean energy, but it remains a technological challenge that we are still working to overcome. The conditions required for fusion, extremely high temperatures and pressures, are difficult to achieve and maintain. However, research and development in this field continue to advance, bringing us closer to the day when fusion could become a practical and sustainable energy source. Nuclear fission is the process that powers most of our current nuclear power plants. It is a fascinating and complex process that has revolutionized the way we think about energy production. It relies on a chain reaction, where one atom splitting triggers the splitting of others, releasing a tremendous amount of energy in the process. This chain reaction is meticulously controlled within the reactor to ensure a steady and safe release of energy. Imagine a single domino knocking over an entire city of dominoes. That's the power of a nuclear chain reaction. Each split atom releases neutrons that go on to split more atoms, creating a self-sustaining reaction that can continue as long as there is fuel. This energy is released in the form of heat, which we use to boil water and produce steam. The steam is then used to drive turbines, converting thermal energy into mechanical energy. The steam then drives turbines, which in turn power generators to create electricity. This process is highly efficient, allowing us to generate large amounts of electricity from a relatively small amount of nuclear fuel. It's a remarkably efficient process, capable of generating vast amounts of power from relatively small amounts of fuel. A single uranium fuel pellet, for example, can produce as much energy as a ton of coal or 149 gallons of oil. Nuclear fission offers a unique combination of high energy output and low environmental impact. This makes it an attractive option for meeting the world's growing energy needs while minimizing our carbon footprint. Unlike fossil fuels, which release greenhouse gases and other pollutants into the atmosphere, nuclear power plants produce electricity with minimal carbon emissions. This is crucial in our fight against climate change, as reducing greenhouse gas emissions is essential for protecting our planet. This makes nuclear power a potentially attractive option for reducing our reliance on fossil fuels and combating climate change. While renewable energy sources like wind and solar are also important, nuclear power provides a stable and reliable source of energy that can complement these intermittent sources. Of course, no technology is without its drawbacks, and nuclear power is no exception. The potential for accidents, while rare, is a serious concern that must be addressed through rigorous safety protocols and ongoing research. The process of nuclear fission produces radioactive waste, which requires careful management and long-term storage. This waste remains hazardous for thousands of years, posing a significant challenge for the industry. And the potential for accidents, while rare, is a serious concern that must be addressed through rigorous safety protocols and ongoing research. High-profile incidents like Chernobyl and Fukushima have highlighted the importance of safety in the nuclear industry. Fortunately, advancements in technology are continually improving the safety and efficiency of nuclear reactors. New reactor designs, such as small modular reactors and thorium reactors, promise to address many of the current challenges associated with nuclear power. Researchers are also exploring innovative solutions for managing nuclear waste, including recycling spent fuel and developing long-term storage solutions. These efforts are crucial for ensuring the sustainability of nuclear power in the future. As global energy demand continues to rise, nuclear power will likely play an increasingly important role in our energy mix. By investing in nuclear technology and addressing its challenges, we can harness the promise of nuclear fission to create a cleaner, more sustainable future. In conclusion, nuclear fission offers a powerful and efficient means of generating electricity with minimal environmental impact. While it is not without its challenges, ongoing research and technological advancements are paving the way for a safer and more sustainable nuclear future. The promise of nuclear fission is immense, and with continued innovation and commitment to safety, it can be a cornerstone of our efforts to build a cleaner, more sustainable world. If fission is the controlled splitting of atoms, then fusion is the art of bringing them together. While fission involves breaking apart heavy atomic nuclei to release energy, fusion is about merging lighter nuclei to form a heavier nucleus, a process that releases even more energy than fission. This process, the same one that powers the sun and other stars, involves fusing lighter atomic nuclei, such as hydrogen, into heavier ones like helium, releasing unimaginable amounts of energy in the process. The sun, our closest star, has been performing this natural fusion for billions of years, providing the energy that sustains life on Earth. Just a small amount of fusion fuel, such as deuterium and tritium, could theoretically power an entire city for years. Deuterium can be extracted from seawater, and tritium can be bred from lithium, making the fuel supply for fusion both abundant and accessible. Fusion has been the holy grail of energy production for decades. Scientists have long dreamed of harnessing the power of the stars to provide a nearly limitless source of energy for humanity. The potential benefits are enormous, from reducing our dependence on fossil fuels to mitigating climate change. It promises clean, safe, and nearly limitless energy with no greenhouse gas emissions and minimal radioactive waste. Unlike fission reactors, which produce long-lived radioactive waste, fusion reactors would produce only short-lived radioactive byproducts, making waste management much simpler. Imagine a future where energy scarcity is a distant memory, where we can power our world without harming the planet. fusion energy could provide a stable and sustainable energy source, enabling us to meet the growing energy demands of our global population while protecting our environment. However, achieving practical fusion power has proven to be an immense scientific and engineering challenge. The conditions required for fusion are extreme, with temperatures reaching millions of degrees Celsius and pressures that are difficult to sustain. The temperatures and pressures required to initiate and sustain a fusion reaction are staggering, demanding cutting-edge technology and innovative approaches. Containing the hot plasma, where the fusion reactions occur, requires advanced magnetic confinement systems such as tokamaks and stellarators. Despite the challenges, scientists and engineers around the world are making significant progress toward realizing the dream of fusion power. Research institutions and private companies are developing new materials, improving plasma confinement techniques, and designing more efficient reactor systems. Large-scale international collaborations, such as the ITER project, are pushing the boundaries of our understanding and bringing us closer than ever to a future powered by the stars. ITER, the world's largest fusion experiment, aims to demonstrate the feasibility of fusion as a large-scale and carbon-free source of energy. The ITER project involves 35 countries working together to build and operate a tokamak reactor that will produce 500 megawatts of fusion power. This collaborative effort represents a significant step forward in our quest to harness fusion energy. As we continue to innovate and overcome the technical challenges, the dream of fusion energy becomes more tangible. The pursuit of fusion power is not just about creating a new energy source, it's about building a sustainable future for generations to come. With fusion energy, we can envision a world where clean, abundant energy is available to all, where our children can grow up in a healthier environment, and where our planet can thrive. The journey to fusion power is long and complex, but the potential rewards are worth the effort. As the global population continues to grow, so too does our demand for energy. We rely on energy for everything from powering our homes and businesses to transportation, communication, and countless other aspects of modern life. But our current reliance on fossil fuels comes at a steep environmental cost. The burning of fossil fuels releases massive amounts of carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and contributing to climate change. The consequences of climate change are already being felt around the world, from rising sea levels and extreme weather events to disruptions in agriculture and ecosystems. Nuclear power offers a potential solution to this pressing challenge. Nuclear power plants emit virtually no greenhouse gases during operation, making them a valuable tool for reducing our carbon footprint and mitigating the effects of climate change. By transitioning to a more sustainable energy mix that includes nuclear power, we can power our world while minimizing our impact on the planet. This shift requires careful planning, investment in research and development, and a commitment to safety and responsible waste management.